Presentation is how to manage multiple network technologies by single OpenDaylight controller. The subject is one of projects at Okinawa Open Laboratory. We have started this one from last year. Last year, we developed POC to verify interconnection between private cloud with OpenStack and Office system through OpenDaylight. You can see the result on our website. Today, I would like to talk about our new research and development activities in Okinawa Open Laboratory. Here is today's agenda. First, we will introduce you our laboratory. Then, I will share my challenge and motivation to this topic with you. I will show some tests and results for this topic. Then, we will share a use case with you. Finally, I will summarize our topic and show you my future plans. If we have time, we will have Q&A at the end of the presentation.
Okay, so first I introduced about the introduction of Okinawa Open Laboratories. So I'm Takashi from employees of NEC and co-working with Okinawa Open Laboratories. So today that with sometimes about 10 minutes introducing the Okinawa Open Laboratories. Okinawa Open Laboratories is a non-profit organization established about 2013 May 2013, about 2 years ago. So mainly member is NEC and NTT Communications and Eager. Eager is a network company, a startup small company in Japan. And they are thinking about how to create innovation in SDN and cloud using the open source. So our Okinawa Prefecture government is supported our notion and funded for us. So we created Okinawa Open Laboratories 2 years ago. And our laboratory is based on the Okinawa Prefecture, that is a south area of Japan and the island, very warm and good island. Many travelers are going to Okinawa, so that's a good place in Japan. And our mission is research R&D activities, our practical application and dissemination of advanced information communication technologies. So we think that cloud and SDN is now becoming the platform for many users or vendors. So to make innovation in the SDN cloud field, we are our vendor is not doing our R&D only inside the company, is not practical for creating the innovation in the field. So we have to collaborate and creating the collaboration of innovation in this field. So from this notion, we are doing the activities like verification of new technologies on the development use cases or reference models. The international conferences or education or training that we are using the many seminar or education program in the Okinawa area. So and Okinawa is very near from Taiwan or Korea and other Asian countries. So we exchanges with communication with Taiwan or Korea, exchange engineers, and creating a test bed. So we are, and that is the concept, our concept of activities. Upper side is market or users, and the downside is the OS development communities. That means providers of technology providers. Our laboratories sit on the middle of a market and development, and by doing this, we are creating the use cases and technology verification and creating the reference model or the promotion. And for these activities, we are communicating with other partners, open source based foundation, Linux Foundation, OpenStack Foundation, or Open Networking Foundation, or inside Japan, OpenStack User Group, or in Japan. Also, we are our members now. So that will show in the another slide. Many vendors, system integrators, or telecom carrier or academia joined our activities, and these are jointly working. Also, sorry. And this is the technology scope of our activities. The center of control and management software is our target. And of course, we are creating, thinking about use cases with many users or some users or engineers. So, and in Okinawa Open Laboratories, in telecom carriers are thinking about NFV and also OpenStack and SDN. And network side, that is end-to-end network is our focus. So this is our current members. Now, 47 members in total in July 2000 this year. There are vendors, system integrators, telecom, and many academias. And also many, there are from Taiwan or Korea or China, startup or SDN, technology vendors. And we are developing a test bed for doing many activities on the SDN cloud. That is our test bed concept. In our test bed is a unique feature that the user can do in the bare metal resources such as bare metal server or bare metal switches. So user can choose the server or switches from our list by our GUI and doing the choice in the OpenStack version and choose the resources and create the cloud and they deploy the application and run the system or testing. And our resource is cloud-based, so user can back up the whole configurations or data or the server's disk or snapshot the backup, and user can anytime restore all the configuration and or data. So user can restart the test many times, creating reserving the resources from our website and using the preparing resources, the server and switches, and restore the whole configuration from backup. In this testbed, we are doing the many activities as a project. So one of the project we are doing the OpenDaylight. today's session is talking about POC of using the OpenDaylight. We think the OpenDaylight is many southbound protocols that will fit it to the mixed environment of networking technologies. So now the question explained later. So we are doing the POC from last year and doing the creating the system for mixed environment in open flow and layer 2 switches. So yes, so that please explain about our POC.
Okay, I will talk about today's subject from now. Let's start. As we know, OpenDaylight controller can easily manage open-flow network. Here are our motivation. OpenDaylight have a lot of southbound protocol, OpenFlow, BGP, SNMP, and so on. So I had a question. That is, can OpenDaylight integrate any southbound protocol and manage any networking technologies? This is important to users. Users want to make the networking system simple. They want to manage their network more easily. They want to avoid any problem in their own network. I believe OpenDaylight can realize them. We want to know how OpenDaylight manage each network technologies such as OpenFlow, VLAN, and VPN, and so on. This is a simple case. Can OpenDaylight manage this? Usually, everyone uses some networking technologies together in their system. I think that most of users still use legacy layer 2 switch. Here is my first step to manage the mixed network environment. Can OpenDaylight manage networking in OpenFlow switch and L2 switch mixed environment? I tested OpenFlow and L2 switches by using OpenDaylight. I want OpenDaylight to manage both networking. To do this, OpenDaylight have to meet the following three things. First one is to manage OpenFlow topology in mixed environment. Second one is to recover paths during path failure. Last one is to reconfigure L2 switch. I use two projects to do this. One is VTN Manager, and other one is SNMP for SDN. The reason why I choose those two projects is because I want to manage L2 switch by SNMP and manage OpenFlow switch by OpenFlow protocol. On the following testings, we use OpenDaylight version lithium in virtual and physical network environment. This is the first testing. Can OpenDaylight get topology from OpenFlow switches if there is L2 switch between two OpenFlow switches? Who can answer? The answer is no. OpenDaylight sends the order to OpenFlow switches. Then OpenFlow switches use LLDP for OpenDaylight to manage these switches. In this situation, OpenFlow switches which receive the order from OpenDaylight cannot send LLDP. This is because LLDP does not transfer through a neighbor, which is not managed by OpenDaylight. So we stopped using LLDP to find topology in OpenDaylight. We have started using broadcast address instead of LLDP. OpenDaylight can get topology even if there is a L2 switch between switches, or between OpenFlow switches. This is the second testing. We want to check if a host can send a packet to another host after changing VLAN. The configuration is as following. We use 4 OpenFlow switches and insert L2 switch in this position. Port-based VLAN is set in the L2 switch as following VLAN 10 between the L2 switch and OpenFlow switch 4. VLAN 10 between the L2 switch and OpenFlow switch 1. VLAN 20 between the L2 switch and OpenFlow switch 2. OpenDaylight manages all OpenFlow switches. Then we use BTN to make port map between OpenFlow switch 1 and OpenFlow switch 3. OpenDaylight can make a flow path from OpenFlow switch 1 to L2 switch, then OpenFlow switch 4 upper path. In this configuration, we want to check what happened if link failure occurred between L2 switch and OpenFlow switch 4. To make this situation, we removed cable between the L2 switch and OpenFlow switch 4. Then change the VLAN 20 to VLAN 2 at lower port in L2 switch in this picture. Between L2 switch 1 and OpenFlow switch 2 VLAN ID change it from VLAN 10 to VLAN VLAN 20 from VLAN 20 to VLAN 10. The result is what we expected. VTM changes the flows in OpenFlow switches. Host 1 can send a packet to host 2 through the lower path. We know we have to test in much more situations, such as what happens if L2 switch have more paths. Please remember what we try to do. How can OpenDaylight manage OpenFlow and L2 switches in mixed environment? The OpenDaylight cannot manage both together so far. What do we need to make it realized? The first need for OpenDaylight is to detect events such as link failure. A link failure from a L2 switch. OpenDaylight doesn't know what happened in the L2 switch. The second one is to automate switching to the right path. In our testing too, we have to change VLAN in the L2 switch manually. To change VLAN in L2 switch automatically, we need to do extra work since OpenDaylight doesn't have this function to automatic. Finally, OpenDaylight needs to know topology in the mixed environment. We have checked this in our first testing. As we see before, we have to use broadcast address instead of LLDP. To solve the issues we saw before in OpenDaylight, we will introduce the solution which is Orchestrator. What is Orchestrator? This Orchestrator is an application which integrates each project of OpenDaylight easily. OpenDaylight has a lot of features. However, it is difficult to integrate each project. I am developing this Orchestrator which can integrate each project to make our motivation realized. Just remember, my motivation is for OpenDaylight to manage mixed network technologies. This Orchestrator has following features. Managing the topology of mixed network. For example, it can manage the topology in OpenFloor and its switches mixed environment. Second one is monitoring the status of each network. This Orchestrator detects not only a status of OpenFlow switch, but also status of L2 switch by SNP trap. For example, it can detect link failure, link up from L2 switch, and so on. Last one is configuring logical network between each network. A user can build logical network without knowing physical network. For example, as you see in our testing too, it is convenient for a user to maintain connection between two hosts when the physical networking connection is changed. Let me show you what's the benefit on the Orchestrator. How do you manage both underlay and overlay network? You can do this if you use this Orchestrator. For example, when you build overlay network by VPN, You can check status of not only overlay but also underlay network and control them as you want. If OpenDaylight can manage network technologies in any mixed environment, don't you think more and more users will adapt OpenDaylight to their system? This orchestrator provides the function for OpenDaylight. Finally, it will benefit for users to use OpenDaylight if each project of OpenDaylight is integrated, because they want to manage their own network system easily. We can provide these functions to OpenDaylight by using this orchestrator. I will show you how to integrate V10 and SMP4 SDN later. This is a use case high availability for two hosts. Using the orchestrator, these two hosts maintain connectivity when one passes gets failed. This configuration is same as testing 2. At first, link failure happens on upper path between L2 switch and open flow switch. This link failure is occurred by removing the cable from L2 switch. Then the notification event for link failure is sent to the orchestrator by SMP trap. The orchestrator detects the SMP trap and searches another path on this topology. If it finds another path, it sends a request to SMP4 SDN to change the path. SMP4 SDN changes the VLAN of L2 switch by using SNLP. Then OpenDaylight controller updates the OpenFlow topology and update flow table in OpenFlow switch by V10. We will show you the demo for our use case I showed you on previous page. Before starting the demo, something I have to mention first. During my video recording time, I have some network issues, and it caused latency. I will let you know at that point. Sorry, not clearly. Demo movie start. Torii. We can see operations for starting the orchestrator on the right upper windows shows. The right bottom window shows ping from one host to check connectivity between two hosts. And the left window shows the log for the orchestrator. The host sends ping to the other host. Let's start the orchestrator. Actually, we use Tomcat for the application. Let me change directly to Bing. Okay. Now we start Tomcat by issue command startup .sh. Tomcat is started. Let's see the log for the orchestrator on the left window. The orchestrator .log is saved under varlog orchestrator. The orchestrator checks the status of L2 switch by SMP trap. Okay. We use this HP switch as our L2 switch. The light blue cable is connected to our open flow switch. Let's remove the cable from port 3. I will show you what happens when removing the cable from L2 switch. Let's see the log. Okay. This means orchestrator gets SMP trap from the L2 switch and dispatched message to SNP for SDN. Sorry, not clearly. SMP trap, detect SMP trap log. This one, VLAN ID change by SMP for SDN. What happens to the connectivity? Let me check the host window. The host cannot send ping. As I told you before, this is a problem for network, not for OpenDaylight controller or the orchestrator. Let me do fast forward because it takes a while. Okay, now host can send a ping to the other one again, which means SMP4SDN changed VLAN in L2 switch and VTN manager changed flows to the other path. That's all. Let's go back to my presentation. Until now, we have made it possible to integrate the projects in OpenDaylight easily by using the Orchestrator. We have some future plans. The first one is make OpenDaylight Controller high availability. This is the most important thing for commercial business. Second one is develop the orchestrator to manage different network technologies. We developed POC level orchestrator at this moment. Third one is test others for the mixed environment. Fourth one is make templates of network configuration and automate network. Fifth one is integrate OpenStack neutron. Last one is research use cases for user to use OpenDaylight. I just explained all the topics for my presentation. To conclude my presentation, I would like to summarize some important points. The first one is the difficulty for OpenDaylight to manage mixed environment. The second one is the orchestrator provides OpenDaylight with the function. As for the last one, please join Okinawa Open Laboratory to develop together. We appreciate today's opportunity. I hope this presentation will be helpful to you. Thank you for listening. Okay, we have time. Is there any question? Any question? Okay.
What was the latency from the time that you took the wire out to the time it discovered the other switch? How long did it take?
In this environment, what?
Right, right. But how long did it take for the orchestrator to detect the failure?
The orchestrator can detect the big error and change the VLAN. So overflow plugins of OpenDaylight.
Any question? Okay. If you have some question, please send to this email. Thank you very much.
To create innovation in SDN and cloud using the open source. So our Okinawa Prefecture government is supported our notion and funded for us. So we created Okinawa Open Laboratories 2 years ago. And our laboratory is based on the Okinawa Prefecture, that is a south area of Japan and the island, very warm and good island. Many travelers are going to Okinawa, so that's a good place in Japan. And our mission is research R&D activities, our practical application is, and
We will introduce you our laboratory. Then I will share my challenge and motivation to this topic with you. I will show some tests and results for this topic. Then we will share a use case with you. Finally, I will summarize our topic and show you my future plans. If we have time, we will have Q&A at the end of the presentation. Presentation is how to manage multiple network technologies by single OpenDaylight controller. The subject is one of projects at Okinawa Open Laboratory. We have started this one from last year. Last year, we developed POC to verify interconnection between private cloud with OpenStack and Office system through OpenDaylight. You can see the result on our website. Today, I would like to talk about our new research and development activities in Okinawa Open Laboratory. Here is today's agenda. First, uh,
Okay, so first I introduced about the introduction of Okinawa Open Laboratories. So I'm Takashi from employees of NEC and co-working with Okinawa Open Laboratories. So today that we sometimes about 10 minutes introducing the Okinawa Open Laboratories. Okinawa Open Laboratories is a non-profit organization established about 2013 May 2013, about 2 years ago. So mainly member is NEC and NTT Communications and EGA. EGA is a network company, a startup small company in Japan. And they are thinking about how dissemination of advanced information communication technology. So we think that the cloud and the SDN is now becoming the platform for many users or vendors. So to make innovation in the SDN cloud field, we are our vendor is not doing our R&D only inside the company, is not practical for creating the innovation in the field. So we have to collaborate and creating the collaboration of innovation in this field.